Oh, I think I had to click go live. This is like what the fourth stream, and I'm still trying to figure out how to do this right. Oh, there we go. To click. Okay, it is streaming now. All right. All right. Well, yeah. Let's get started. Are you ready to go? Well, thank you, Mark, for joining me again, so that I'm not just talking to myself. Um, so I wanted to do some follow up on some of the topics that we covered um, last weekend, which was the high level overview of how the code is structured. And as I was breaking it down into individual chapters, I was kind of regretting not emphasizing certain points. So, I'm like, hey, it's good. We can do it now. So, by way of review, let me get rid of my SeedSigner. And somewhere in here, there we go, is the spreadsheet we're looking at. I can make it bigger. So, very quick review. We had the notion of a central controller, which is sort of like conceptually like a web server. We have individual views, which present information to the user and receive back the user's input and kind of route you back to the controller. So basically, the view is each atomized piece of functionality that the SeedSigner is going to take care of. Essentially, a one-to-one correspondence between a screen that you see on the SeedSigner in the UI, like a page that you would navigate to. Yeah. So for each page in a SeedSigner flow, there is one view per page. And I'll try to use the word page. Right. You load a web page. And then we had the screen class, which handles all of the display of that page. Receives any data that it needs from the view, and then it just figures out how to draw itself. And it relies on a number of reusable UI components like buttons, input units, things like that. So one thing that should be clear from this organization is that a view has no idea what the screen even looks like. So, in the current world, a view might be, like we were looking at the, let me bring it up. We were looking at the SeedSigner tools menu view, right? And so the view knows that there are going to be 3 items in a button list on this screen, but that's all it knows. It just knows that there's going to be 3 options on this screen. It doesn't know, and it doesn't care how the screen object here is going to render and present these 3 options to the user. And so you could imagine a future version of SeedSigner that supports, a number of different display screens. And so let me bring my camera to the front here. So like imagine that we have a version of SeedSigner that can run on this little screen, this all-in-one board. And so with this smaller screen, you might be only able to fit 2 rows of text on this little screen. Or maybe it's even weirder, and maybe the UI is rendered, this way, right? Vertically. Yeah, right? And then so you're gonna have a totally different UI just to select, amongst 3 options on a screen like this. And so if that day ever comes, if we've done this right, we shouldn't have to rewrite, in theory, we shouldn't really have to rewrite any of these views. The views should exist as is. Like there just will always be a view that says, hey, here are the menu items in the tools page. And then it's up to the screen implementations to decide how to present that to the user based on what kind of hardware you're running on. So currently we render it in this, 3-button list, the way that we have on screen. But yeah, in the future, something like this little screen, it might just be, instead of having these icons and these rounded orange button selections, it might just be like the primitive original SeedSigner, where it's just a list of text, where it looks like old school 90s DOS prompt, where it's like text row 1, 2. Yeah, right. And then you have to scroll to even see option number 3 that's listed there. But that would be all decided in the screen that's used for that particular display. And so, when things get more advanced like that, let's bring back our tools views. So here's our tools views, our tools menu view. It's setting up the buttons, and it's just going to be these 3 options. And it's going to pass it off to our button list screen. But, in this world where, I'm just making things up right now, but if, let's say we have something like hardware display equals that little TTGo screen that I just showed you, then let's instantiate a different kind of thing, like, a text only list screen, perhaps, right? And then we feed that data. But if we're on the normal hardware, we can go ahead and instantiate our normal button list screen. Something like that, where the view still doesn't know the details of how this is being drawn. It's just adding support for different display hardware, which require different, UI renderings. And so in your view layer, other than pointing to your target screen that you're going to rely on to render all of this and present it to the user, the view here should have, again, no idea how to draw itself. It should have no information about any sort of pixel level details. And so if you're coding a new view for SeedSigner, and for whatever reason, if you get tempted to draw something within your view class, then you've just done something totally wrong, because the view doesn't draw anything. That only happens inside of a screen. Exactly. Yeah. And just keeping that, enforcing that separation, even when it's kind of silly, but just for the point of cleanliness, so that if something is, let's say something is rendering funny on your new view, or we look at your submission, we look at your pull request, and it's rendering funny, and I want to go and I want to look at your code and see what you've done and try to debug what this rendering problem is. I'm not going to look for your rendering code in views. I'm going to look for it in Marc implemented something in the tools screens. And, I'll see what you've done at the pixel level in your screen. Things like, let's see, I'm just picking calc final word done screen. Okay. So here it is, generating a text area to show us the final word that was calculated for your mnemonic. It's going to pull up an icon with a fingerprint that shows your selected seeds fingerprint. And I guess that's all we need. And then all the positioning to get it, placed on the screen in the right place. But that's happening in a screen. And so just very, very straightforward separation. And a lot of this was because of, no shade to the original SeedSigner code, written by SeedSigner the man, and then refined by Nick. But the prior to the version 0.5.0, there was much less separation of this kind, and it just made the code very hard to just work with in a lot of places where, like, okay, you just calculated your mnemonics final word, and you're displaying it to the screen. So the code to accomplish that is really short. Like, this is all it is, right? It's just saying, pull up the text area, put in the final word, pull up an icon text line, show the fingerprint, right? So simple. It's like you almost can't screw this up, right? or it's very simple to debug because it's only doing, this one thing. It's a very atomic chunk to look at. Very easy to debug. And then, so if we look at, okay, so that screen is being instantiated somewhere in a view, so we can look for that screen. Here we go. And again, my naming convention, tools, calc final word, done, view. It's the exact same naming convention, but the view that goes with the screen. Yeah, and so here, it's just setting up the parameters that the screen needs to know about. Like, hey, by the way, what was the final word, right? Like, that's the whole point of the screen, just to pass in the final word. And then once you're done, there's some work to do to convert your mnemonic into an actual seed that you can operate with, and then to route you on to your next destinations. But again, on the view side of things, it's very simple and very short. It doesn't do much because by design, we don't want it to do much. We don't want any of this to get too complicated. And then another thing to look at is, let's take a specific flow, actually. Let's see. Well, we had briefly looked at the xpub export flow. Let me shrink all this down, collapse it, find the X. So in views, seed views.py. So like at line 451, we've got the beginning of the seed export xpub flow, which is selecting your sig type, single sig or multi-sig. And, again, it's very simple. All it's asking is pick one of the two. That's it. That's all it does. It's really dumb. And then it forwards you to your next destination, which is the script type view, and then yeah, I mean, we're just and actually, yeah, yeah, this code is fine, but it's a little redundant. But anyway, and it doesn't. This view is very simple. And even here, it would be very tempting to say, like, okay, this is dumb. It's asking one question, and it's always going to ask a follow-up question, which is, okay, now that you've picked single sig or multi-sig, what script type? As in native SegWit, nested SegWit, taproot, whatever. And so it would be tempting in this very simple view to say, you know what, why don't I just ask the second question, right? Why do I have to like go through this destination routing stuff when I know, and here's the next step, I know all I have to do is, create another button list screen that says, hey, select one of these script types. And, so again, going back to the version of the code before 0.5.0, we would have single gigantic Python functions that would do all of these question steps, like all in one giant function, right? And so it would be like, okay, ask these two questions, render that to the screen, wait for the response. Ask these next two questions, render the screen, wait for the response. And you'd have to read through hundreds of lines of code to finally get to the part that you care about. And it's just so hard to read that code, to maintain it. People may or may not love my naming convention because it is very long, right? Like this is a long, line 521, seed export xpub custom derivation view, right? That's a long name for a class, but because this is so atomized, it's trivially simple to read through this and jump to the one piece of functionality that you care about, that you need to debug or you need to enhance or whatever it is. And if you read through just the names of these classes, you can see the flow. I mean, so seed is because we're in the seed tools. So everything is prepended with seed. Export xpub is the overall activity that we're engaged in. And then the first step is sig type. Okay, select your sig type. Then the next one is script type. Okay, then the next one is a side option for custom derivation, which most flows aren't going to need if they don't select a custom derivation path. And then it's coordinator. Select if you're using Sparrow or Spectre or Nunchuck or Blue Wallet. And then there's a warning, as in, sharing your xpub can leak your privacy. And then you see all the details of your xpub, and then you see the QR be displayed, right? So without even opening any of these classes, I can just read the name of the class and follow the flow that's implied through all of this. And so if I know that I have a bug in my coordinator selection, it's so easy to find it, and the code is so short, right? Like this, the selecting your coordinator is whatever this is, 20 lines of code, maybe 25. And so again, if you're writing a new pull request to add a feature to SeedSigner and your view is doing more than one thing, that probably means you've overstuffed your view. And sticking with this analogy of a view is like a single web page. If your functionality requires 2 web pages to accomplish, that means 2 separate views, no matter how simple and stupid the view is. Like we have an entire view just for the warning screen, just to say, hey, this could leak your privacy, look out. And then we continue on our business. But we isolate everything for the point of cleanliness. Right. Yeah. So actually, that's right here, line 576. When we pass in the button data to select your coordinators, that's pulled from your user's settings that are on the SeedSigner. And so, if you haven't customized your settings to have persistent savable settings, the default is to keep all of the coordinators active, enabled. And so this will fetch the list of enabled coordinators from settings and feed that into your button list screen. And it has to be dynamic because you can disable coordinators. Like most people are only going to be using one coordinator for their, day-to-day usage. And so it would be annoying if they had to stare at, what will be an ever-growing list of coordinators. Like, the day will come where we might have, who knows, 50 different coordinators in our list. And nobody wants to scroll through a list of 50 items on the tiny SeedSigner screen. And then also, and we mentioned this briefly, yeah. Um, I mean, I would say it is a little redundant. So if we wanted to optimize this, what I would actually do instead is let's cut this query out. Query, it's just a lookup from in memory. So coordinators list is that value. And then if the length of the coordinators list that I just fetched is 1, we're going to skip this screen entirely because we know there's only one coordinator to pick from. Something like that. There, and yeah, I mean, there's different ways to do it. And yeah, and see, I'm dumb here too. This is redundant. I don't have to fetch this again. There we go. So yeah, I think that's an improvement. I mean, yeah, right. Yeah, yeah, and anything related to the settings, getting information out of the settings is a little cumbersome. Like this call references this constant, this other settings call references other constants, and it returns an array that we're selecting out of. But the settings, again, we're going to need to get to the settings on a subsequent stream because they're kind of a deep topic all on their own. Yeah, the more rich and fully featured the settings are, or any feature, the more complicated it gets. And the settings were made, designed to be to add incredible flexibility to SeedSigner in ways that I think most people don't even realize, beyond just like activating and or enabling and disabling a coordinator. The settings can go way beyond that. But in order to support all of that amazing flexibility, it adds code complexity to just pull a simple settings value. Right. Right. Yeah. Right. And then that border between views and screens goes two directions, where the view shouldn't know how to draw the screen, but as much as possible, the screen should know almost nothing about Bitcoin. So, like, let's see. I was just looking at the. So now I'm in the PSBT views Python file. So views slash PSBT views. And if you go all the way down to line 458, it's the PSBT finalize view. So like 476 has this quiet little line that says PSBT dot sign with, right? And so like that under the hood, that little sign with method is going to be doing a lot of work, right? Because that's literally signing the PSBT with our key. But if we look, actually, let's go further back than that. Something like, sorry, I know it's the entire point of SeedSigner. It deserves more fanfare than that. Okay, so I'm looking at line 233, the PSBT address details view. So this is your series of review screens as you're going through the PSBT signing flow. So the address details view, as it says, shows the recipient's address and the amount. And so this is the screen where you're supposed to be confirming that the outgoing recipient's address is correct and that the amount isn't insane. And so it starts at 233. Okay, so it does some work to set up the title, create the button data, and it's going to instantiate its custom screen, which is a PSBT address details screen. And it's going to get the address of the recipient and the amount that the recipient is going to get. And so if we follow into that and we go to the definition of that screen, so now I'm in PSBT screens, PSBT address details screen. So that's line 575 in this file. It's expecting an address coming in, which is just a string, and an amount, which is an integer sats. And what is it going to do? There's a BTC amount GUI component, which can draw the amount in Bitcoin terms. It can draw it in Satoshis. It can draw it in my preferred BTC Sats hybrid format. And the default is a threshold format where it, depending on the size of the amount, it'll either show it in Bitcoin or it'll show you in Sats. But so this screen is even dumber than you would think, because it doesn't even have to worry about how to draw the Bitcoin amount. It just says, hey, draw these total sats, right? And then this Bitcoin amount component, it figures out if it should draw it in Bitcoin terms or sats or BTC sats hybrids. We can take a look at it really quickly. I don't want to get into too many of these details. But let's see. Right, and all this ticky tacky, delicate work you have to do to be precise with decimals. Decimals in Python and pretty much any programming language are not or floats rather, are not precision variables. And so there's this dedicated decimal class that comes built into Python so that we can get exact decimal precision down to 8 decimal places like we want for Bitcoin, without any rounding issues and those sorts of things. But anyway, so yeah, so this this BTC amount component is doing all that work to handle the amount as satoshis, decimalize it, if that's a verb, if it needs to, depending on which display format, and then actually drawing the text, with styling, and those sorts of things. So going back to the screen, okay, cool. It got the amount taken care of. Now its next job is to show where those sats are going to go. They're going to go to a Bitcoin address. And even here, this screen doesn't even have to know how to draw a Bitcoin address, because there's a component for formatting a Bitcoin address. And let me pull up my an actual PSBT so we can see it on screen. Where's my SeedSigner? There we go. Okay. Okay, where are we? Oh. Scan. Oh, I don't know if I can do this with the mic in the way. This is gonna be challenging. Come on, SeedSigner, you can do it. You can do it. There we go. We got 1/3 of it. Oh, we got it. Okay. Looks like I've already got the seed on board. Okay. So the screen we've been looking at is we've been looking at this screen. So let me highlight that. Let me get off of this flashing one. Here. Okay, so webcam. So this is the screen we've just been going through. It has a Bitcoin amount at the top, 0.1 Bitcoin. It has a receive address in the body of it, and the address has been formatted to highlight the first and last 7 characters of the Bitcoin address, and the others are visible. It looks hard to read on the webcam, but it's more visible on the actual real life screen, or to the human eye. And so this is the screen that we've been looking at. It's all it has to do is instantiate this Bitcoin amount, 0.10 BTC, and then instantiate this formatted address object to spit out the address down there. And then it draws the button at the bottom to forward us on to next recipient. And that's about it. I don't even know what this code is doing here, to be honest. Okay, so I'm rendering the amount. I'm rendering the address. I'm not sure what this is doing, but... Oh, I see what it is. No, so it's just a little bit of the image library we're using. It just has some specific, procedures. And so I'm creating a temporary image to work with. This is basically like image scratch space. And I'm passing that into the object that knows how to render the Bitcoin amount. I'm passing that into the object that knows how to render the addresses, or the address. I tell it to actually render. So now it's writing its pixels to that temporary surface. And then I'm just taking that temporary surface, and then I'm finally going to paste it into my display. And so it's basically just the amount and the address were rendered off screen, and then the final result was pasted in at this final step down here on 621. Yeah, and the screens have this is a little bit of a deeper dive, but since we're here, each screen object, each screen class has this list of paste images. So I'm appending what I just rendered off screen here, or down here. I'm adding that to my list of paste images, and so every time this screen renders itself, it just says, "Hey, do I have any paste images? If I do, draw them." That's it, or paste them in rather. So at the base screen class in line 27, at the very beginning, we see that every screen has these paste images built in, and components for that matter. So let's see if there's another example. Well, so let's stay here. In the base screen, when it is told to render, it's going to go through its paste images and it's going to paste them onto the actual surface that will get written out to the screen. So basically, it's just a place that you can stuff things that you need to render. And it's just, hey, render this image at these coordinates for any screen. And it's just automatically built in. And then I said that there's also a self.component. So every screen has a list of its own components. So like if we find if we go back to our old friend, the base top nav screen, it's instantiating a top nav here. It's storing it into self.topNav, and then it's appending that new top nav into our components list so that this will automatically get rendered on each cycle when the screen is updated. So any other UI, so every UI component will either be, for the most part, added to components, or if there's an image to paste in, it'll be added to paste images. And then once you've done the append step, you don't have to worry about drawing the thing anymore. It'll just automatically draw itself whenever it needs to. All right, but that was kind of a side tangent that I didn't necessarily need us to rabbit hole to go down. But the point being, the screens should be pretty dumb. Like I said, they shouldn't understand really anything about Bitcoin. They're just there to position text, to set up buttons, and that's it. And so if you have a more complicated page, like, let's back up in the PSBT. So let's go back to this this ridiculous, this is simply the PSBT math screen. Okay, so now I'm in, so let's go to PSBT screens, and there should be, here it is, line 447, PSBT math screen. So this is the screen that's rendering our Satoshi math here. So if you look at its initialization variables, the total number of sats coming in through the inputs for this PSBT, plus how many inputs are there. How many of those sats are being spent out to external recipients, and how many of those are there? What are you paying in fees on this transaction, according to this PSBT, and how much are you getting back in change? So the math screen is expecting you to have already sorted out, parsed the PSBT and figured out, where, how many sats came in, how many sats came out, where are they going, how much is fees, how much is change. And then again, it just renders it. But if we look at the matching PSBT view for the math screen, I love my code comments here. I've literally redrawn the screen in my code comments. So in PSBT views, now we're on line 198. All right, Okay, so here the we have a PSBT parser object, and this is actually a good segue to the next chunk I want to talk about. The PSBT parser, you can guess what it does, and it has already parsed our PSBT, and so we can just ask it for all of this data. What is the total input amount? How many inputs were there on this PSBT? How much are we spending? To how many recipients? How much are we spending in fees? And how much is coming back in change? So if you were writing this math screen and you just sent the screen, so imagine instead of, all this setup to feed data into the screen, we could have a version of the code of this math screen where we just say PSBT equals, let's assume that we have the PSBT somewhere in here. I don't remember where it is right now, but right. And we just pass in the PSBT itself into this math screen, right? Because it has all the info we would need, right? And then if we were to do that, then in the screen, in the post init here, okay, I have a self.psbt, but then I would have to start parsing it, right? To get its information out, to figure out how many inputs are there, how much do the inputs total. And at that point, you're doing like Bitcoin logic inside of your screen, which as much as possible, exactly should not happen. The screen should not know what Bitcoin is. And so as soon as you find yourself doing that, just stop, right? Like any sort of data preparation. Right. Yeah. Okay, so that's just kind of your it should make your spidey sense tingle if you're doing that kind of work inside of your screen. The whole point of the view is that it's going to prepare all of the data that the screen needs in order to present itself. But the screen itself, for the most part, shouldn't have to know how to prepare that data on its own. Now, of course, now that I've said that, if you or anyone out there finds a screen that's doing too much work, call me out on it and either tell me to fix it or fix it for me and submit it as a pull request. I'm generally pretty disciplined, but there's going to be judgment calls where you'll be like, "Hey Keith, but what about this screen?" And I'm like, yeah, you're probably right. I should probably pull that out and move it into the view." But it's just that's the basic mental discipline and philosophy that we want to try to keep consistent in here. And even if I've failed at it in places, do as I say, not as I do. Right. That's true. That's true. Okay, so now I said that our PSBT parser was doing a lot of work for us. So where the heck is that? This is a totally different kind of object that we haven't gone into detail yet. We've really only talked about views and screens and components and the controller. But what I don't really have a place for in this diagram is the model. So maybe what I need to do is insert a column here and have in the web context, this would be our database schema, let's say. And in the Django Flask world, these are model classes. And in SeedSigner, using the same terminology, it's a model. So, and this is to, you know, represent, I don't know. I'll have to work on better text for this, but something like that. Represents a logical object we often need to manipulate. That explanation will definitely be rewritten when I have a little more time to think about it. So it's really more like stick with the schema level. So in a website, you'll have like users can log in. So somewhere in your database, you'll have a concept of a user or a concept of an account in your database. So the account table exists in your database. You will likely have an account model class that captures the fields of that account table that's in your database. And then you'll have functions that act upon the account object, like account.create, account.delete, account.update. Yeah, right. Yeah, login user, change password, reset password, all those sorts of things. So in SeedSigner, if we look at our models directory, and we're a little bit mushy with this section. Seed, okay, is a very solid concept here. So this one at least is not mushy. We have an object that we're defining called a seed. It can be created with a mnemonic, optional passphrase, and then which language the mnemonic is in, because BIP39 has more than just English words to pick from. Although I guess not many people use the non-English BIP39 word list. But anyway, for yeah, I don't think there's Portuguese, but there's like, I don't know, 3 Asian languages, Chinese, Japanese, Korean. I think there's French and German, obviously English and Spanish. Yeah, there definitely is Spanish. But anyway, for SeedSigner, what we call a seed is the and I'm fuzzy with these terms myself, but seed, your key, whatever you want to call it, it's these. Let me back out of this. I'll pull up my screen so you can see what I'm talking about. Back out of that. No, cancel that. There we go. So at a basic level, this first seed here is stored in a seed object that's defined by this class. So, and it does basic things like it takes your mnemonic and it will generate the underlying private key that's derived from that mnemonic plus any optional passphrase. So we generate our seed, and we're calling this mnemonic to seed function, giving it the mnemonic and any passphrase that we have. And I'll come back to how this is working, or how this comes about. But the seed itself has a bunch of utility calls, like, okay, return the mnemonic as a string, return it as a list, get it in a displayable fashion. Same thing for the passphrase, set the passphrase, get the fingerprint with the associated seed. That's what we display in the UI, this 73C5. Get xpub given a specific derivation path, and network as in mainnet or regtest or testnet. So that's how we get your xpub to export, one simple little function. And so the models just wrap up this concept of what is a seed in SeedSigner. It's an object that is important all over the code. And so it's just one solid definition of what is a seed, what utility functions does it provide, and things like that. But while we're here, we can look under the hood a bit more. So I said we'd come back here. So this mnemonic to seed. So how do you take a BIP39 mnemonic phrase and convert it to a private key? Well, this BIP39 package is doing it for us. Well, where the heck is that defined? So if we go to our imports at the top of the file, expand these. So I'm in models seed.py. So if we look at the very top, line 4, we have from mbit import this BIP39 package. And so here, mbit is an external dependency. So it's a library written by Stepan Snigarev, which I reference often, because it does all of the real Bitcoin work. So like, we're looking for, so it's doing the mnemonic to seed conversion for us. So if we look at the mbit source code, so now I've got mbit open on my new window here, and there's this BIP39 module. So in BIP39, we can go mnemonic to seed, and we can look at what it's doing. And like, okay, let's see, mnemonic to bytes, follow this through. There we go. So now it's going through each word that's passed in, and it's looking for that word in the BIP39 word list and finding the index of where it appears in the word list. And then it's just doing a whole bunch of work to convert that index into a binary seed value for all of the input mnemonic words. And then it has to do the checksum and make sure that the checksum is valid, which involves, a SHA-256 here, right? And comparing them. And so like Stepan has done all of the work. This is his code. We are in mbit BIP39.py. So he wrote all of this, and he's done the work for us. So SeedSigner just imports his mbit library and this BIP39 package, and we just say, hey, Stepan, would you please convert this mnemonic to a seed for us? Thank you very much. And so it's part of the reason. So short side tangent here. If anybody is using SeedSigner to manage their generational wealth, or what we hope will be generational wealth someday, and you hear me say something dumb and ignorant about some technical aspect of Bitcoin, like, don't panic yet, because like I didn't write, nor did Nick, nor did SeedSigner, the human. We didn't write the hardest parts of what SeedSigner does. That's all from Stepan's mbit library. So like we had seen the sign with call, so in PSBT views. So let me find that. Sign with, that's on line 476 of PSBT views. So this is when we're actually signing a PSBT. So that sign with is on a PSBT object that Stepan has defined. So if I look at the mbit source code, he has a PSBT module, and in that module, there's a sign with class, or not class, but function. And so here is Stepan's sign with function to sign a PSBT. And so he's doing some work, checking some things, going through each of the inputs on the PSBT and seeing if you can sign each of those inputs. There's like all these exceptions for if it's taproot, we got to have these other considerations. Like we're getting, deep into like really hardcore Bitcoin protocol level, fundamentals here, et cetera, et cetera, et cetera. And then when we're finally able to sign, Stepan's code says HD key dot sign. So where is that? That's also within Mbit. I think it's in base key, or no, it's in private key. So that is in his EC class. So EC stands for elliptic curve. So now we're going even deeper. Elliptic curve math is what secures all of Bitcoin. So within the elliptic curve, this EC module, he has a class called private key. A private key can sign. So when the private key signs, so now we've gone so deep, right? Like we asked Stepan to sign the PSBT with our key. We handed it off to his code. His code has done all this analysis and processing. And now it's finally time to sign the PSBT. What does he do? He calls this SecP 256K1 module, and he tells it, hey, do an ECDSA sign, elliptic curve digital signature algorithm sign. And he's passing in the secret, which is basically the private key, and what is to be signed. And so what is SecP 256K1? Well, that is a module taken directly from Bitcoin Core that is being pulled into Stepan's Mbit package here, so that we are using the exact same Bitcoin Core code to do this elliptic curve operation, which is signing this PSBT. So that was a long journey of traversing down these complexities and these dependencies. But so SeedSigner relies on Mbit to do the really hard work, and then Mbit relies on Bitcoin Core to do the elliptic curve math. And so this maybe. So I say maybe because if you look in Mbit, so Bitcoin Core is all C and C++, and we're obviously running in the Python world. So Stepan has done all this work, this C types, to basically interface the Bitcoin Core C code with Python. But that relies on having a compiled binary of that C code in order for the Python to run on your machine. If the binary isn't available, you just can't use Bitcoin Core's SecP 256K1 library. So instead, there's a Py SecP 256k1.py file, and it says at the very top, this is a fallback option if the library can't do the C types bindings. And so what this file is it's all of the SecP 256k1 functions, but implemented 100% in Python. So this is our fallback. If we can't use the compiled version, we have to use the pure Python version, which is going to be less efficient and it'll take longer. But so like here is the pure Python way to sign that PSBT. And this is the stuff that I don't understand any of it. So But anyway, so and um, I have not. And part of it is like my strongest skill set is as a app level developer. And so what I mean by that is like writing this elliptic curve math, right? That is not my strong suit. Like this is so deep in the super hard cryptography details. And then in the Bitcoin Core code, it is this SecP library is the fastest elliptic curve math library on the planet. I mean, it's very specialized. It's only for the specific curve that we use in Bitcoin, but still, it's been optimized by the smartest, most talented people on the planet, and that is just so far beyond me. But if you give me tools, right? You give me Stepan's Mbit library that does that hard stuff for me, right? Where I can just call a signing function and I don't need to know the inner details of how it works, or things like that. My dog's about to start barking. Oh, okay, hang on. I have a surprise visit. So I'm going to have to pause right here. I'll keep the stream running, but I'm going to kill my video and audio. I apologize for this. Okay, hang on. Ah, okay, I am back. Are you there? Okay. Uh, come $5 rich tech me. Now's the time. That's all right. That's all right. I'm defenseless. Yeah, the perils of live streaming. Um, well, I don't actually know if my so I was very confused. The things that I flipped, I think the video affected your view on Zoom, but not what was being streamed out. So my video was still streaming, but I muted the I think I muted the audio for the stream, but not for Zoom, or something like that. I don't know. Um, or maybe I just yeah I don't even know what's happening. But um, anyway, let me wrap up that point. Uh, so sorry about the interruption. Anyway, I was saying I'm an app level developer, which is you give me tools to do things, and I will build cool shit using those tools, right? Like I have a table saw, and a drill press and other things in my garage right now, and I can use them to build, cool carpentry stuff, right? But I'm not mechanical enough to build my own, drill press, let's say. So that's sort of our analogy here. So Stepan is a drill press builder, and then the Bitcoin Core team is like, I don't know, the nuclear fusion engineers that are gonna build a engine to get us to Mars, right? I don't know. They're doing magic, you know, like the the most difficult, most technical parts. They're doing the magic. I don't understand the magic, but I can use the magic by reading Stepan's spellbook. So there we go. There's another analogy for us. Um, okay, so yeah, that's right. Like, yeah, and even if I had read Jimmy Song's book and wrote my own elliptic curve math library, I would not use it to sign my own transactions. You know, like I wouldn't trust it. I don't know enough to know if I've done something wrong with in that kind of code. Now there's a flip side, and you know this is getting a little kind of coding philosophical, but you know just quickly, the downside of these dependencies is that word dependency. Like if there aren't enough eyes on Stepan's code, and if I'm not savvy enough to deeply understand his code, then there could be a bug in his library that we're using. And whereas with Bitcoin Core, there's so many eyes on it. There's so many projects that are using its libraries that there are enough eyes on it. And so if there is a problem, you know, the Bitcoin ecosystem will see it and it'll be addressed. But so I'd say the biggest risk in this arrangement is with Mbit, where Mbit is used. It backs Spectre Desktop Wallet. It's used in the Spectre DIY hardware wallet, which is kind of like a super advanced SeedSigner. And it's used in Mbit is used in SeedSigner. Obviously, there's another cool little hardware project called Crux that I believe uses Mbit primarily. But there still isn't a broad enough Bitcoin ecosystem using Mbit to feel as confident about it as Bitcoin Core. I mean, nothing's going to give you this confidence level of Bitcoin Core. But like, you know, a parallel to this is, I don't know a lot about it, but a lot of projects use a Trezor math library where, you know, right, like obviously a signing device has to be able to do this elliptic curve math. And for whatever reason, in Trezor's case, maybe just because it was so early in the history of Bitcoin, you know, Pavel Rusnak or whoever wrote their own math library. And then I think that was used in early versions of the cold card, used in like the Keep Key and, you know, all these other hardware wallets, all these other projects all use this Trezor library. And so once you get enough major projects and companies using the same library, then you can start to have again, a higher sense of confidence that there's more eyes looking at it. There's more skilled eyes looking at it. And so, you know, I don't want to scare people. But I think the biggest risk for SeedSigner is that there's a bug in Mbit, and I just haven't been savvy enough to find it. But it's, you know, lying in wait to sneak up on us. I wouldn't even say that. There are I because I don't understand the cryptography math well enough. Um, you know, I'm sure there's a there's this, like, again, let's say I was writing my own elliptic curve library. I wouldn't be surprised if I could code in a bug in my own library where I leave enough traces where my private key could be reconstructed based on the way I'm producing the results of my elliptic curve math, because I did something wrong in this fictional library. So I wouldn't have, I wouldn't take it as a given. Although in this case, because we're using Bitcoin Core's elliptic curve library, I do think that's an unlikely, problem to have to worry about. But anyway, the point being, so the good news is you don't have to worry about my level of expertise because I don't have a sufficient level of expertise. That's the good news. The bad news is you do have to rely on Stepan's level of expertise. And I mean, I trust his code, and that, trust is kind of the wrong word to use here. I've thoroughly used Mbit for so long now in Spectre Desktop, in Spectre DIY, in SeedSigner, running through the test suites that sanity check, given these inputs, we're expecting this PSBT out or whatever, that I haven't found, any bugs, any serious issues. But yeah, and that's why, anytime somebody, tries to give me a lot of credit for something I've done in SeedSigner, a lot of times I'm just like, no, don't give me credit for that. Like, I'm just the monkey that plugged two wires together, like Stefan was on the other side of that wire doing all the real work. Um, Yeah, well, you get a room full of monkeys at typewriters, and by the end of the universe, one of them has written all of Shakespeare. Right? It's just a matter of time. But no, the thing that I do take more credit for and more pride in is this overall seed signer code structure approach. This views, the models, the screens, the components. That I am very proud of. That was something I can claim as, my true contribution to this project, the organizational sanity of how we get things done, and just the, making what I think were hopefully smart decisions about the flows, about when we have to ask for certain things, et cetera. Anyway, we're getting a little off course, but let's, or was there anything else on that topic? Right. Each table of the database. Um, all right, and that does remind me. So I said we're a little mushy in our models. So seed is an obvious example of, if this was a website, there would be a seed database table. Settings. are obvious, right? It's a giant data store for each person's customized settings. But where things get a little fuzzy are like the PSBT parser isn't something that would have its own database table. It's really a utility class. Like you create your PSBT parser, you tell it to parse, and then you can get all of the details of the PSBT out of it. So arguably something like this should have been in more like, sorry, over here, we do have a helpers section. So it probably belongs in helpers, not in models. And yeah, so our rigor is a little looser and fuzzier in these areas. But they're also, I think they're a little less important because I just view them as very kind of utilitarian, mechanical, straightforward. If they're slightly categorized a little bit wrong, I'm not going to worry about it too much. Yeah, and then same for like encode QR. Again, this is probably something that should have been a utility class because we're giving it all the different possible inputs that can be rendered as a QR code on the SeedSigner. So when we sign a PSBT, we show the signed PSBT back to the coordinator by displaying the signed PSBT on screen. So we pass that into our encoder. Yeah, seed phrase. Oh, so that's like if you're going to export your seed, if you're going to export your mnemonic as a seed QR, you would pass it into your encoder, the entire mnemonic phrase. So, and the only, its only job. Yeah, so its job is to output. Yes, yeah, the seed QR. Yeah. So its only job is to render out, like for an animated QR. There's multiple parts. Render that to an image where the image is a QR code, right? And so this is really again an instance where encode QR should be in some sort of utils, section, and it's not really a model. I think a lot of this models section was pulled from the original code as is, and didn't need nearly as much reworking as the rest of the view and screen layers did for 0.5.0. And so, to be honest, I think I just kind of just didn't give it the same kind of mental focus as those layers did. But yeah, I'm not too worried about it. All right. Yeah. Um, exactly. Yeah. And your views primarily will be using some of these models and utilities. And then in some cases, like encode QR, which is more visual, that's going to be a utility that's used by the screen classes. So, yeah. All right. Good enough for there. So let's move on. All right. So now I thought we would do something a little bit fun, which is let's make a pull request. So first of all, let me look at my, okay, good. I didn't save any of these like little nothing changes we've been making. So I don't have any garbage to clean up. So in the work that I was doing this morning with the PSBT, with that, I realized, okay, this is going to be a pain. I'm going to scan a PSBT again. Back. Let's see. Let me get that on screen. It's over here. Oh, good. It's still up. Okay. Let me move my mic out of the way this time. Okay. Scan. There we go. Much better. Okay. So in this case, oops. All right. Yes, that's the signer. Parse it. Show us all that stuff. Recipient, 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 self-transfer, change. All right, and now I'm ready to approve it, approve the PSBT, sign it. Okay, so here, it's gonna ask which coordinator do I want to export this signed QR code for. So if we look in, let's say I don't need to save these changes. If we look in the, let me close some of these. PSBT views, the finalize view is going to forward us to select our coordinator. So the select coordinator view starts at line 498 in PSBT views. And if we look at, and so it's going to have to set up this selection of, hey, you know, Blue Wallet, Nunchuck, Sparrow, Spectre. But as I was looking at the code this morning, I saw this statement. If the user selects Spectre, then use the QR type that's specific to Spectre Desktop. Otherwise, all three of the other choices use the same default UR2 format. And so this is 518 in PSBT views.py. Let me undo some of these changes. Oop. Yeah, so line 518, it's saying, hey, everyone uses UR2 except Spectre. Spectre uses a different format. And so really, you know, if you look at this, the choices on the screen, it's not really pick from one of these four wallets. It's just, are you using Spectre or not? Because everything else uses the same default UR format. And then, so I did a test. Like, well, what if I do give Spectre the UR2 format instead of its special format? And it turns out this special format was from a while ago, and now Spectre does support the UR2 format. And so all four coordinators could just use UR2. So, hang on, I do have some garbage I need to clean out of this PSBT views file. So let me discard that. Oh, no changes. Okay, it's strange. Okay, so that means that this entire screen that I'm looking at on my SeedSigner right now, asking me to pick my coordinator, is now completely unnecessary. We can just default to this UR2 format, and all of our current list of coordinators, all four of them, are perfectly fine with the UR2 format. So here's our PR. Let's see. Our view that we're looking at on screen right now, it's instantiating the encoder. and it's passing it to a QR display screen. So when I click one of these 4 selections, I'm going to get this animated QR display screen. And let's see. But now that we know we don't need to select the coordinator, so I don't need to be told which coordinator we're using. So I'm going to get rid of anything related to the coordinator. We're just going to go with the default PSBT type. And so I can just simplify this whole thing to always use the UR2 PSBT type. My init on this class is now doing nothing. So I can get rid of the init entirely. There's no reason to subclass it. Okay. And then if I look backwards, we have the screen where we're on line 498, select coordinator view. Well, we don't need this at all. So I'm just going to delete this entire select coordinator view. But I'm going to check. It does have a custom screen, PSBT select coordinator screen. So I'm going to go into that file. So in PSBT screens, I'm just going to delete this whole screen. We don't need it anymore. So that custom screen is gone. Right, we don't have to ask which coordinator do you want to use. So back in PSBT views, I'm going to delete the select coordinator view. I don't need it. And now the only thing left is something was routing to that select coordinator view. So here it is. Yes, and just to be sure, I'm going to do a little find. Yep, it's the only reference in the whole thing. Okay. So let's see what's going on in this if statement in 488. It's the same check. If you only have one coordinator enabled in your settings, then you can skip straight to the QR display. Otherwise, you have to select your coordinator. So now we're not going to have this otherwise. We don't have to check which coordinators you have enabled in settings. We can just return straight to the signed QR display view. And there is no... What's that? Exactly, right. And then we don't have to tell it which coordinator the user selected because we just got rid of that. And so we can remove this coordinator argument. And now this view doesn't need any input argument, so I can delete this view args argument. All right, look how simple our code is getting now. Okay, so we've simplified. Our next destination is just always going to go to the signed QR display. Signed QR display is always going to default to this UR2 format. And we've just completely excised that coordinator selection screen, that coordinator selection page, and its custom screen. It just doesn't exist anymore in this world. And so, all right, let's do a sanity check and make sure we haven't broken anything. All right, so my rsync is always running. So let me hide this. I got my little rsync note down here. It has synced everything. All right, I'm going to pull up my console and I'm going to Control-C to stop my SeedSigner. It is now dead. And then I'm going to rerun it. And I'm going to need my PSBT again. Okay, so now we're running my modified PSBT code. Let me scan my PSBT. My little webcam setup got a little loose and janky, so it's wobbling around on me. All right, I need a seed to sign. which is which one? I think is it this one? Yep. Okay. Good old abandon, abandon, abandon. All right, let me go back to here. Okay, so now, same thing. Review the overview, the math, all these recipients. And then here we go. As soon as we click sign, before our changes, this is when it would ask us which coordinator we want to use. And so now, if I haven't screwed anything up, it'll go straight to showing us the animated QR. Woo! There it is. All right, so it did not have to ask us which coordinator. So that is gone now. Okay, so now that we've tested our change and we're happy with it, I'm going to go to my GitHub desktop because I don't really do things from the Git command line, even though I could. And I'm going to review my changes. So make this a little bit bigger. Oh, this is kind of a limit to how big I can make this, and still be usable. But so GitHub desktop. Okay, so it's showing me I've changed two files. The first file is PSBT screens, and the only change is this big red block. I've just deleted the entire select coordinator screen. So that's my change in this file. Looks good. In PSBT views, it's a little harder to read the diff. So I've deleted this if check on how many coordinators you have enabled in your settings. And I've removed the else case where you would go to select your coordinator. And so this entire if else logic is now removed, and we just by default always go to the signed QR display view. So we skip all of that logic. The entire select coordinator view is gone. It's been deleted. An entire red block wiped out. And then within signed QR display, we've removed the init entirely because we don't have any input arguments anymore to worry about. And then within the run, we're not doing this logic of checking for Spectre anymore. We're just going to say, hey, the QR type is just always this UR2. And so that's it. Those are all the changes we've made. And so I've been making these changes in my dev branch, which matches basically the current lead of where the SeedSigner repo is right now. Dev is the default branch. So what I tend to do is create a new branch, which is I'm going to call it PSBT skip coordinator select is going to be the name of my branch. So I'm going to create a new branch based on dev. That's our working branch, or our working, whatever the terminology is. And then, right. And I want to bring these changes that I just reviewed into this new branch that I've created. I don't want to leave them behind on the original dev. I want to bring them with me into this new branch. So bring them with me, switch to that branch. It shows that I still have these changes in place, and I'm now on my new branch. And I'm going to write a summary, removing step that asks for user to select their coordinator during PSBT signing flow. All right, and I'm going to commit my changes into my local branch here. So commit, all right, and I'm going to publish the branch, and this is to my fork of SeedSigner. So I'm going to publish it into my fork. And so now if we go to GitHub and we go to the Katie Mukai fork of SeedSigner, we see that, hey, we just had recent pushes, this new branch. And so I can then hit compare and pull request. And let me make this bigger. And so if we look at what's being compared, we're looking at my fork, this new branch that I just committed to, versus the parent main SeedSigner repo and its base branch, which is dev. Yeah, so dev is always the default branch. So this is going to show me what changes am I proposing that we put into the main SeedSigner repo. And if I've done this right, it'll just be the changes that we just reviewed. Sometimes there are cases where your Git repo can get a little ugly and you end up accidentally committing changes that you didn't mean to. So that's why, like, I really try to take some time to review the changes that are displayed, in the GitHub desktop here. But then I also review them very carefully. Yeah. And hang on one sec. Let me pause again here. Sorry. Hey guys. Yeah. Oh. I'm just gonna bring her over. We're done.
I just didn't know if you were playing with the camera.
Yeah. Here, wait.
Come on. Come on. Right there. Car furnace. Oh, I don't have that car though. I don't have a car seat.
I just put the leash handle.
We'll be in back.
Yeah. All right. Thank you guys. Okay, I'm back. Yeah, so yeah, I mean I think it's more for my own sanity on my side. So like let's say, so we're going to submit this branch as a pull request. But like what I was working on this morning was the progress bar on those animated QRs. But that's not necessarily ready to go. And so it's in its own branch so that I could do this other work in the clear, so that these two branches don't depend on each other. But then even if both are submitted as a pull request into the main repo, if I were to kind of merge these two together, like if it looks like they're both going to be part of 0.5.2, right? Like, oh, I can just go ahead and mash those together and then work off of that. But then it just gets, and then here I'm working on Taproot signing for SeedSigner, but that's not ready to go yet either. And so it makes it simpler to keep your changes into distinct branches so that each, like basically dev is your baseline. And so that any changes you make are just one step away from baseline. So we've done this very specific change off of dev. And then the animated QR progress bar is one step away from dev in its own direction. And then Taproot signing is a whole bunch of other changes. But you just don't want to get into like Git nightmares where well, I wrote basic taproot signing to depend on animated QR progress, but it turns out we don't want that one in, so I need to pull that out. Like it's just, it, you know, for anyone who's old enough to know Ghostbusters, right? Don't cross the streams. Just keep them in their own branches to keep it clean. Yeah. So anyway, these changes look good. I'm gonna look at my commit comment got mangled on the way in, and this is gonna be a little hard for me to do live, but if we look at the SeedSigner pull requests, when we're just browsing them here, so, like, notice this new feature bracket that just, it helps it stand out to explain what this pull request is for. Update README. Okay, that's very simple. Add this. Like, by the time this Taproot PR is complete, like it's in a draft state right now, it'll probably have a better title, although it's fairly self-descriptive right there, self-explanatory rather. But so for this, I would say like, PSBT signing flow change, and that change is omit, delete, skip, remove, remove unnecessary, perfect. Prompt to select coordinator. And then now that I have a nice title for my pull request, and the reason I'm spending a little extra time at this stage is this, like we see here, once I create the pull request, that kind of goes before the SeedSigner world to be reviewed by anyone who wants to look at the pull requests here. And so this is kind of a formal declaration of the changes that we would like to submit to the project. And we are asking the project, hey, I think this change is worth adding. I think it's worthy of adding to your project. Please consider. And so this is almost like if you're, applying for a job, you might have like a nice cover letter or something, right? Where you want to present yourself in the best light. And so you're offering your changes, but you want to present them in the best light in organized fashion. So it's worth spending a little. You can. Right, exactly. Yeah, you can edit the title, and I do often just because I'm fussy about these sorts of things. And some people might think it's silly. Like I write at this point, I write more code than anyone else for this project, but I'm still putting myself in the mindset of how do I present this new feature, or how do I present these changes? How do I present this change in flow to the entire community? Right? Like just because I want something to happen doesn't mean it just gets rubber stamped in, right? Like the SeedSigner, the man, and Nick are the only two that have commit privileges on the repo. At the end of the day, it's up to them to understand and test and accept the change. So I also want to do as much as I can to, at the very least, explain to them what is this thing, why does it matter, and just have that documented. Now, in reality, the three of us talked about this morning. I was like, hey guys, I don't think we need this, do we? So they already know this is coming, but it's also for any other person that comes to the project and looks at the pull requests. We should have the mindset that this is not just the SeedSigner Nick Keith project. This is this is open source. It's open to anyone to review and contribute. If you look through one of the other pull requests, so my Taproot one is much bigger. There's a whole like comment like thread that can happen. So anyone off the street could write a comment and say like, hey, wait a minute, in this file on line 72, why are you doing it this way? Right? And then I'll look at their comment and be like, oh crap, you're right, that was dumb or whatever. And so you can have a whole conversation about the changes that you're putting in here. And that's really what you want. So I'm going to explain why this flow change makes sense. Coordinator selection only mattered if the user selected Spectre. The other three were always using UR2 UR format. Now that Spectre supports UR2, this coordinator selection step is unnecessary. Okay, I think that's good enough. But sorry, say that again? Right, exactly, yeah. But so even this simple change, like, if you were a brand new person coming into this process, I think it might be a little surprising that there's even this much explanation and, this kind of modest level of care put into the title for such a simple little change. But that's just part of the mental discipline and the professional approach that we want to take when it comes, to making changes to this code base. So I'm going to create my pull request. So now if we look at our list again, there we go. PSBT signing flow change, remove unnecessary prompt to select coordinator. And there we go. And so like, for example, if Mark, if you were to look at this, you can write your own comment. And so in the Bitcoin Core world, they want lots and lots of eyeballs on changes. And so since you have seen and reviewed these changes already, and I'm going to pretend I'm you right now, in the Bitcoin Core lingo, you could just say ACK, all capitals, ACK, which again, right. Well, I guess, I don't know, maybe I guess that's where it comes from. As a newbie, when I first saw people saying ACK, I thought that meant that they really hated it or that there was some huge, terrible problem with it. Because I thought they were literally saying like, ACK, oh my God, it's terrible. But what it means is ACK as in like, yes, I endorse this, or I reviewed this, or I think it's ready to go. That's what ACK means. Or you could say NACK, which is the negative, like, no, I don't like this, right? I don't want this merged. And so if you look at Bitcoin Core issues and pull requests, you'll see a series of ACKs and NACKs and then discussions about them. And so that's part of the review process that happens there. So, and this is such a trivial change, but just for the fun of it, if you're going to be spending time in the SeedSigner repo and starting to make changes, it would be great for anyone, including you, Mark, to go through these pull requests that you had nothing to do with, but review the changes, run them on your local SeedSigner, and then weigh in and say, like, give us some ACKs, give us some NACKs, or give us suggestions, or if you see bugs, or if you have questions. So if we review the changes, okay, So let's say, I don't know. So like I can hit this little plus here and I can say like, why did you blah, blah, blah? Like I don't understand, or this doesn't make any sense. This isn't clear. And, it might be that you misread the code or you didn't understand the lines that preceded it. But if somebody's asking a question about a specific line of code, maybe that means that the code needs a comment on that line, right? So maybe I need to go back and say, where was this? This was line 498 in PSBT views. So 498 here. Like maybe I need to say like all coordinators use this format, or something, right? Like based on a comment, I can go back and add extra clarifications. Right, right, right. And when you or anyone asks a question in here, like the question might be really terrible, right? It might be a dumb question, but again, it's a sign that that part of the code is just a little harder to read, and so even if the question is dumb or the person was just wrong, if they're like, no, it doesn't, this is always gonna, your math is always gonna result in one, or whatever. Um, they might be wrong. Yeah, right, right. But even if the commenter is wrong, again, that still just might signal a place where, okay, they're wrong, I'm right, but let me walk them through it more carefully in how I lay out the code, and let me reorganize or let me add comments, whatever it is. All right, and so like, and actually, let's see, all coordinators. I'm going to say this. Okay. Use this format. And so actually, maybe that is valuable. It certainly doesn't hurt. And so if I go back to my GitHub desktop, it finds, hey, I've made a change. It's just added this comment. I can go ahead and just, I don't have to write a note if I'm only changing one file. If you change more than one file, you have to write a note in here. But this is just, I don't even have to write anything, but for now, I'll just write a clarifying comment, whatever. It's pretty useless there. So I'm going to commit that to my branch. But because my pull request is connected to my branch, when I come back here and reload my pull request, there's my comment. Right, so my pull request has been updated with all of my latest changes. So now we see my second commit down here as part of what is included in this pull request. So that's it. And then let's see. I'm not sure what the permissions allow. Yeah, like you see some of the pull requests, like this, I feel so bad. This BIP85 pull request, I think it's pretty much ready to go, but it's been languishing here for a while, where it just kind of got pushed down the priorities, and I got busy with other things. And so here, actually, it's a good example where, so Jace has this BIP85 pull request, and then Nick here did some review, and he's a little concerned about all the dependencies that are getting pulled in. Jace responds to it. I come in with notes and critiques, things I'd like to see changed, or things I literally say I dislike something here. Oh no, I'm talking about myself. I just like how I implemented. Sorry, Jace, you're good. I'm the problem. And then other criticisms. The title is slightly vague. And so, we're just being brutally honest about things. And then just because I'm like, squishy and soft, I do say I realize there are a lot of critiques here, but just wanted to end by saying thank you for all your work thus far. Yeah. And so then it's gone through. Right, right. And then Jace did more commits. Um, blah 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 blah. More changes. I had some more changes for Jace. So this has just been a journey. Here we go. May 11th. He's tagging me at Katimukai. These updates are done. Nick is testing it again. But the last action on it was June 13th. So like we had been on a roll. We were really making good progress on reviewing and refining this code and making sure we were all comfortable with it. And then it just kind of fell off as other things kind of got onto our radar. So I do still want to get back to this, but anyway, you can see how these pull requests can have like a whole rich life and journey to get there. And then Nick will go in and he's the one that adds these tags. Like this is an enhancement. This is a bug. This is slated for, or possibly slated for an 0.5.2 release. So he's really the one like managing, doing the maintenance of the repo. All right, so we are right at 2 hours. I was hoping we would be quicker this time. Interrupted by surprise visitors at my house. Nobody came and $5 wrench attacked me. I could have been assaulted live on YouTube. you know? Yeah, yeah. Um, good, good. Yeah, yeah, exactly. Yeah, that was not mocks. That was a real change. And then, as I always need to remember, my shill. Let me get my face out of the way. So this is my LN URL for Lightning donations. Oops, let's see. This is my paynim for for my paynim on-chain donations. I've also forgotten to link to my btcpay.keithmukai.com, my BTC Pay on-chain donations. There's also a pay join BTC Pay endpoint that I'll drop a link to if you want to play with pay joins and donate me some sats. And that is it. So yeah, throw. So I thought of some goals for this because again, I'm still not expecting really anything to come in these donation channels. But I think the first goal should be, Marc, whenever I see you next in person, and I don't know necessarily when that's going to be, I hope to at least have enough donations through this to be able to buy you a beer. Okay, so anyone watching this stream or these videos after the fact, donate enough sats so that I can buy Marc a beer because the man has earned it. And then if we get as a reach goal, if we get a lot of donations, let's get so that I can buy Mark a steak dinner. Sound good? This is it's a it's a 1-for-1 steak match donation program we have right here. All right, sounds good. Well, all right, thank you. We'll talk to you soon, Mark. Yeah, sounds great. All right, I'll see you then. Bye bye.